everyone. Welcome to Balletic Foods presentation. As Alex said, this is going to be a presentation on applications for optimized protein in resource-limited environments, namely space. I'm Faiha Larasanti, and I'll be your speaker for the session. All right, to start off, please allow me to introduce myself. As I mentioned, my name is Faiha Larasanti. I graduated with a bachelor's degree in advanced food science from California Polytechnic State University at San Luis Obispo, which is located in Central California. Throughout my university career and beyond, I've been able to experience many different sectors of the food industry, starting from food service to in-lab quality assurance, all the way to product development. My most memorable and impactful experiences were of Lions Magnus, where I was a research and development intern. I was taking part in the product development of a wide variety of beverages there. And I also was a worker at my university while I was a student. I was a sensory assistant for the Cal Poly Sensory Lab in the food science department. My work there took place during the start of COVID, so as you can imagine, it was much different than it was pre-COVID. It ended up being convenient for everybody. We were able to bypass the whole sensory test monitoring on campus, and we instead sent participants home with samples and instructions on how to conduct their own sensory tests at home. It was a great learning experience for me all around. My interests outside of my study of food science include literally everything under the sun. Environmental science is one. I had a minor in it. I took several trips for lab classes, and it jump-started my interest in sustainable food production. This also stretches to marine bio. I am an avid Monterey Bay Aquarium fan, and I love going to the coast to tide pool. And of course, I am a hobbyist astronomy lover. It's something I've always been interested in since I was a kid. Space has always fascinated me, and during my spare time as a child, I would watch Khan Academy videos talking about planets and space and stars. Shown here is a photo of my sisters and I at the Johnson Space Center in Houston, Texas. We're posing alongside the Apollo 13 crew. So this interest of mine somehow brings me here today to connect my study with astronomy, talk about space food systems, and how my company's product, which is a cultured protein, could possibly fit into the realm of space food. Speaking of Balletic, allow me to formally introduce my company at which I work, which is called Balletic Foods. We are a food technology company with a home base in Davis, California, and our goal is to help revolutionize the modern world's food systems. In order to promote sustainability within the food industry, our team is working on developing animal protein without the animal. Using complex microbiological processes, we are able to produce a high quality, high nutrition animal protein without the financial and environmental costs of producing actual livestock. So you might wonder why we're motivated to culture animal protein. Well, animal protein, especially compared to plant proteins, are high in nutritional value, and they tend to contain a much wider variety of all 9 essential amino acids, which all humans need to ingest to live healthily. If you don't know, the indispensable amino acids, also known as essential amino acids, are the 9 amino acids needed in our human diets, since our bodies cannot produce them naturally. To consume all essential amino acids on a plant-based diet, you'd have to ingest a large amount of plants in a large variety. So animal proteins are kind of ideal to eat daily. So animal proteins are thus more complete to think about it nutritively. However, animal proteins currently on the market can contain carcinogens, and as I mentioned before, the typical method of production of animal products leads to drastic environmental change, which poses health risks, many resulting from pollution. Not only that, the ingestion of these animal products can also lead to health problems itself. The way meat, and therefore animal protein, is produced in current times may be considered highly unsustainable. Balletic Foods has observed that there is currently no method to consume high-quality nutritive animal proteins without the negative side effects of animal culture, which is where Balletic comes in. Based on our projections, shown in this chart is an overview of how Balletic protein fares against animal protein produced in other ways. I'll break down the chart and Balletic protein applications in the following slides. All right, so let's start to break it down. As you can see, the cost of production for balletic protein is several times lower than that of animal-based protein, as well as cell-cultured protein. Side note, this cost includes everything, including energy, land, and environmental damage. Plant-based protein is also low cost, though it is reflectively much less nutritive. And as I said before, balletic protein is animal-free, produced using much smaller scale processes. As of right now, cell-cultured protein still requires the use of the animal, and of course, animal protein sourced from an animal will not be animal-free. Plant-based protein is aligned with balletic protein in that both do not require animal use. Moving on to nutrition, balletic protein, unlike animal-based protein, is free of carcinogens and large amounts of saturated fats. With balletic protein, you also don't have to worry about the possible health risks that come with ingesting typical animal protein. Also, like animal protein, balletic protein is high in quality. We'll talk more about that in the next slides. As for environmental impact, balletic protein poses almost none, as opposed to animal-based protein. Next, let's talk about production time. The production time of balletic protein takes only a few days, whereas plant-based protein usually takes months, and animal-based protein takes years to grow the animal, of course. Also, throughout the entire balletic protein production process, the risk of pathogens remains low. For animal-based protein, producers must be concerned with all types of pathogenic contamination, since they, of course, deal with living animals that are naturally prone to microbiological activity. As you can see, balletic protein is very comparable to that, to plant protein in terms of production costs and environmental impact, but it has the added plus of having a much higher nutritive quality. In addition to the benefits of lowered costs and heightened protein quality, balletic protein will also be applicable to all types of food products. As a non-animal based meat protein, it can be used in bars, namely protein-rich energy bars, making it perfect for athletes. It can also be used in shakes, snacks, and powders, as well as being made into meat alternatives or replacements, so that it can be eaten by all kinds of people with all kinds of diets, from meat eaters to vegans and vegetarians. The list goes on. Without the heavy impact of animal agriculture and production, the possibilities of balletic protein are endless. Right. Let's talk about protein quality. To discuss that, I need to define DIAS. DIAS stands for Digestible Indispensable Amino Acid Score. It's a method of measuring protein quality presented by the Food and Agriculture Organization, also known as FAO, in 2013 to replace the current protein ranking standard. DIAS measures the digestibility of amino acids throughout the digestive tract, and it can help us visualize what kinds of proteins the human body can absorb more efficiently. The higher the score, of course, the higher the quality of the protein. Scores under 0.75 have no quality claim. Scores of 0.75 to 0.99 are high quality, and scores above 1 are considered excellent quality. So let's take a look at the DIAS scores of the proteins listed here. Let's start with 80% lean ground beef. The score of 0.97 is considered high quality. Beef protein, we can assume, is extremely digestible and contains all the indispensable amino acids. Then moving on to pea protein, we have a score of 0.62. This is under 0.75, so we cannot claim that pea protein is of high quality based on the digestibility score. And not only this, but unlike beef, pea protein is not a complete protein, meaning it does not have all 9 essential amino acids. This isn't surprising, as there are very few plant proteins that are complete. Whey is a milk protein, of course, it's derived from cows. It is an excellent quality protein with a score of 1.07. Again, this is an animal protein, which is complete in its amino acid composition. And in comparison, we project that balletic protein will have a high digestibility score of 1.20 or over, being both a complete protein as well as something that is more easily absorbed during consumption. Balletic protein is designed and engineered for optimized performance in every way. If you want to know more about the details of balletic, we will be posting more on our website in the future, so be sure to look out for that. So moving on, because of the balletic protein's nutritive, high quality, and low cost nature, it's suitable for applications outside of everyday consumption. It can also be used in hospital meals for patients who might want to eat less but require more nutrition. Currently, common hospital foods used for these purposes include protein drinks and soups. Balletic protein may be easily incorporated into foods like these to add to a patient's nutrition and help improve their health. For the same reason, it may be an ingredient in military foods for quick, efficient, and on-the-go consumption. This would be very similar to the application of energy bars in that they would be portable and long-lasting, as well as ready to eat on a whim. And of course, it can be used for what we're all here to know about, space nutrition. For space food, applications would compile the purposes of both hospital and military foods. It would need to be portable and long-lasting, as well as nutritive in a small package. But the catch is astronauts need food that they enjoy eating. Space nutrition must consist of tasty foods in order to help or motivate our workers in space. And balletic protein is here to fulfill that need. There are a number of reasons why balletic protein would be suitable for food or an ingredient in space. For one, it's nutritious. Its amino acid composition will keep astronauts healthy and ready for missions. As an all-in-one protein, it doesn't have to be consumed in large amounts for the nutrition to be absorbed. So it doesn't have to be taken in large amounts to space. It's also versatile. As an animal protein, as a non-animal meat protein, it is able to be incorporated into many different types of food, such as bars, beverages, entrees, and it would be a perfect ingredient for a space cuisine because its inclusion will have an extra level of nourishment to tasty foods. And of course, balletic protein is also readily available and convenient. This is partly due to the versatile nature of the ingredient, as well as its shelf-stable nature. As an isolated protein, it can be kept for long periods of time until consumption without refrigeration, freezing, or cooking, etc. Another reason balletic protein is available and convenient is its potential to be made in space during missions. Let's discuss this. Balletic protein may be useful in space applications in more ways than one. Of course, food with the protein as an ingredient may be taken from Earth to space, but it possesses even more potential than that. This lies in the possibility that the process of producing balletic protein may take place within the controlled environment of a space shuttle. The process of making balletic protein is shown here. The potential of the process lies in strains developed on Earth, which may be taken into space so that they can ferment during transport, and that the protein may be purified and isolated to be made into a food ingredient all in one space. Also, both on Earth and in space, the fermentation process for making balletic protein is extremely flexible. It may be adapted for lab environments, big or small, and the process itself is quite localized. It doesn't need to be shipped anywhere at any point of the process like meat would need to be, nor does it need to drastic measures of preservation such as refrigeration or freezing as an isolated protein. For these reasons, balletic protein would be a useful ingredient and a source of nutrition in space. To conclude, the potential of balletic protein in space is endless. Because it is a non-animal meat protein, it is a complete source of nutrition that is highly efficient in digestion, and it's a one-stop shop as far as protein sources go. Not only this, but it's a meat substitute that removes all the cost and damage that animal agriculture would require in production. And of course, because of all of these benefits, balletic protein may be a likely candidate for in-space nutrition as an ingredient and food. So it may be able to be taken into space mid-process so that astronauts themselves can choose how to apply the protein into their diets. Right, open for questions now.
Great, thank you. And thanks for shedding kind of some additional light on the applications there. I just want to comment that it was I love how you said everything under the sun has never had so much meaning before. So it makes
exactly
very fitting here. I wanted to ask about the benefits to astronaut mixing their own ingredients, right? And this is not something you typically hear about because everything is usually prepared on Earth and then sent up. But we are talking about kind of longer term missions, 2.5+ year missions. And so how can you imagine that, the astronauts would be mixing their own ingredients?
Right. I think the benefit in having an ingredient up in space for balletic protein is that, well, a major concern for space food is that astronauts want to eat food that they want to eat, as in they want food that tastes good, they want food that they would eat on Earth. So having the ability to customize their food using balletic protein as an ingredient that they can add to anything they want to eat, it would be really great for them. It would motivate them to eat more. And of course, that's important for long-term missions.
You mentioned you were at Cal Poly. Can you imagine that, potentially we would have actually a food for space program in the food science program at Cal Poly?
Yes, actually, I think it's something that we can definitely look at, because the aerospace engineering program at Cal Poly is also really big, and the potential for them to collaborate with food science is pretty great, because agriculture is also a pretty big area of study at Cal Poly. So I wouldn't doubt that would be a great potential study for them.
So you mentioned, I hear the term high quality protein quite a bit. And based off of that dias, were you kind of saying that a high quality protein is any protein that scores above a certain range? Is that right?
Right.
Okay, I see. Okay, so if it's what is that range?
So 0.75 to 0.99, any score of that value is considered a high quality protein, and anything above a score of 1 is considered excellent quality.
Okay, I see. Okay, cool. Awesome. I think the only last comment I have is that, would you ever have like a customized balletic protein for like a specific individual, not necessarily like an astronaut, blending their own kind of milkshake, but maybe a balletic protein powder that's designed specifically for astronaut A versus astronaut B?
Yeah, that's one of Balletic's goals, is to be able to cater to a lot of different consumers. So we will also be able to do that, create different types of ingredients for different types of people.
Cool, great. Well, thank you very much.
All right, thank you.